Hello students, this is a video about factoring the GCF, which stands for greatest common factor with polynomials. In this video, I'm going to be showing you what a polynomial looks like and how to identify the GCF from multiple terms and then try to pull it out from those terms. First, let's take a look at some of the pictures that I found online. One of these pictures talks about the number of terms. This is an example of a polynomial. This one has 3 terms. This is a specific type of polynomial called a trinomial. What is a polynomial? Well, we're going to get to that definition in a second. Here's another picture that I found online that I thought was pretty useful. These purple values are the coefficients. They're coefficients because they're being multiplied by variables. These green numbers, or green letters I should say, are variables. They're letters that stand for a value that we don't know at this time, called them variables. The exponent is a number on the top right of a variable or a constant or a coefficient that tells you to multiply it by itself that many times. So for example, x squared means x times x, so that's an exponent. Operators are like plus, minus, or multiply, or divide, anything like that. It just tells you to perform an operation. An operator tells you to perform an operation. And then a constant, this purple, or maybe I guess it's a little mauve. I'm not really sure. Not good with colors. This is a constant. It's a number that does not have a variable being multiplied by it. It is all by itself. And just so you know, this constant is actually -7 because it takes that operator and uses that as its value. So this is -7 as a constant. All right, let's talk about the definition. Polynomial. It's an expression written using constants, variables, and operations. It's a little bit of a broad definition, but that's because it encompasses many things. Poly meaning many, nomial meaning, in this case, terms. So for example, all of these that are written down here are polynomials. Let's get to know some of them a little bit better by classifying them. The next screen is a classification screen. And you can classify polynomials in terms of whether they have 1 term, 2 terms, or 3 terms, or more than that, right? If it's got more than 3 terms, it's just called a polynomial. There are other names for it, but you just call it a polynomial. But there are special names for polynomials that have 1, 2, or 3 terms. For example, this -5pq, we call it a monomial because it's got 1 term. There's a lot of stuff going on here, but we separate terms using those operators. Remember operators from before? An operator would be plus or minus in this case. Since there's no operators here, there's a negative sign, but there's no subtract and there's no add. So this is 1 term. This one is 2 terms, so it is a binomial. I know it's 2 terms because there's a 2L, a 2W, and an operator in between them. This one, there's a lot going on here, but it's only a trinomial, not more than that, because 18a to the third b squared, these are all being multiplied by each other. This is 1 term. Here's another term, 9ab to the 4th. And then here's another term, -36a to the 4th b. This is another trinomial because there's 3 terms separated by operators. Here's a binomial. I know it's binomial because it's separated by 1 operator there. Even though there's no variables here, it's still using a constant, so I can call this a monomial. It's only 1 term. Here's a binomial. N squared minus 9 is a binomial because it's got 2 terms there. And here is a trinomial. Okay, hopefully that makes sense. A monomial's got 1 term, no operators present. A binomial has 2 terms. There's going to be 1 operator in between the 2 terms. And then a trinomial's got 3 terms present. There's 2 operators there in between the 3 terms. Let's talk about the concept of greatest common factor. If I'm looking at 2 numbers, I can identify the greatest common factor. This is a younger kids thing. This is more like maybe a 6th grade concept. The greatest common factor is going to be the number that is able to divide into both of those numbers evenly, and it's the largest of those types of numbers. It's the greatest number that can be divided into these 2 numbers. So generally, in order to figure this out, I'm going to factor the numbers. To factor means to find the factors of. And remember, that word factor is a word that indicates multiplication. So like I said, we're trying to find 2 terms that multiply to give the original term. So if I'm looking at 14, it's actually fairly straightforward. I'm going to take 14 and factor it into 7 times 2. Do the same thing with 63. I know that 63 is equal to 7 times 9, so I'm going to factor it like that. Further factor down 9 into 3 times 3. So this is called prime factorization, factoring until we can't factor it anymore. Once I've done this, I can identify the factors of each of the original numbers that I was looking at. For example, the factors of 14 are 7 and 2. The factors of 63, the prime factors of 63 are 7, 3, and 3. I'm not choosing 9 because 9 I broke down even further. Okay, so now I can list out both of these numbers as a list of prime factors. And once I do that, I can identify that there are factors that are in common. So what I'm going to do is I'm going to try to identify all of the factors that are in common and then put them back together to form a greatest common factor. In this particular case, 7 is the only number that appears in both lists. So the greatest common factor of 14 and 63 is 7. As an exercise for yourselves, try to do a prime factorization for both 32 and 80. You're going to break it down into factors until it can't be broken down. Pause the video, try this one out, and then come back to see if you got it right. All right, 32 is real simple. It's just 2 times 2 times 2 times 2 times 2. And then for 80, it's 5 times 2 times 2 times 2 times 2. All right, a lot of 2's going on here. Now let's write the lists of factors for 32 and 80 to look like this. See that 32 is just 2 multiplied by itself 5 times, so 2 to the 5th power, and then 80 looks like this. Now, in order to find the greatest common factor, I mean, 2 is a common factor between both of them, but we need a greatest common factor. So we're going to pick all the factors that appear in both lists, all the factors they have in common, and we're going to pick them in pairs. So for example, if I pick a 2 off this list, I got to pair it off with a 2 on this list. We're going to go through and try to pair off as many as we can, and then that's going to be our GCF. Looks to me that there's 4 2's and 4 2's that are paired up. That means our GCF is 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, now that this brief review of greatest common factor regarding numbers is over, let's take a look at it looking at polynomials. We're going to do something very, very similar to what we did before. We're just going to find the factors of each of these individual terms. For 4x to the third, I know 4 becomes 2 times 2. But you remember that x to the third means I'm multiplying x by itself 3 times. So here's what the factorization of 4 looks like. Okay, now you can see the factorization of 4x to the third went to 2 times 2, and x times x times x, because x to the third means 3x's. X squared means 2x's, and then 8 got broken down into 4 times 2, and then 4 got further broken into 2 times 2. Now let's write them as lists of factors. See, 4x to the third is 2 times x times x times x, that's here. And then 2 times 2 times 2 times x is 8x squared. So let's identify the common factors here. And then we can write them together, multiply together as the greatest common factor. See that there's 2 2's and 2 x's in both lists that pair off. There's one more x left over here and one more 2 left over here. And the GCF becomes those 2 2's and those 2 x's. Now let's multiply these together and simplify them a little bit. And I get that the GCF is 4x squared. Now what I'm going to do is I'm going to rewrite this expression as a factored expression. In other words, what would it look like if I took this 4x squared out of both terms? What I mean by that. 4x to the third minus 8x squared is equal to 4x squared, which is the GCF, times something. Now I know that factoring is the opposite operation of multiplying. So could I find 2 polynomials that multiply together to give me that original expression? Well, 4x squared times something is going to give me 4x to the third. And then 4x squared times something is going to give me 8x squared. The trick is to look for the pieces that are left over in our prime factorization lists. For example, if I look back at the 4x to the third, the thing that was left over is x. For 8x squared, the thing that was left over is 2. So those are the 2 pieces that are left behind in the parentheses. Here's what I mean. Take the x that was left over in this list and put it here, and I take the 2 that was left over in this list and put it here. Why do I do that? Well, let's think about it. If we take the GCF, which is 4x squared, and multiply it by x, what would we get? We'd get 4x to the third. And if we were to multiply 4x squared by negative 2, what would we get? Right, we would get negative 8x squared, which is our original expression in the first place. The original expression is 4x to the third minus 8x squared. So here's what the objective is. We're trying to factor using the greatest common factor. In other words, we're trying to rewrite this expression, whatever expression we're given, as a new expression of 2 different terms being multiplied by each other, right? Finding 2 terms that multiply to give the original term. So Here's our correct and complete answer. 4x squared is the GCF. I'm going to write that first, and then I'm going to write whatever's left over in the parentheses. Okay, hopefully that makes sense, but if not, we'll do a little practice here. This is a little bit longer. There's 3 terms here, so we're going to have to do our prime factorization 3 times rather than twice. And also these numbers are a little bit bigger, but I'm going to walk you through a little bit of a way to take a little bit of the load off of you. So let's try doing the first one first. Bad, we split up 18 into 9 times 2, and then 9 splits up into 3 times 3. There's 3 A's, there's 2 B's. Next, I'm going to split up 9AB to the 4th. So the second term broken down, 3 times 3 times A times 4 B's, and then we're doing the negative 36, A to the 4th, B last. This one's not too bad either. 2 times 2 times 3 times 3 times A, B, right? Now we're going to do the same thing that we did before, list them out into 3 different lists. I'll put these ones one on top of each other because there's 3 of them here. Seems like a lot, but this is a good way to do it, right? We list out all the factors. Now we'll pick the ones that they have in common. Now we need to find triplets, right? Ones that are in every single list. So for example, I'll do the first one, that there's a 3 in every single list. I'm going to highlight all those triples. Then there's another 3 in every list. So I'm going to do that again. I don't see a 2 in the second list, so I'm not going to highlight 2. I'm going to keep on going, do the same thing as I do it here. Turns out that the only ones that are in common on all 3 lists are 2 3's, an A, and a B. So our greatest common factor looks like this. There's our GCF, which is 9AB. Now we're going to rewrite it as a factored form, just the same way that we did here. Here's the original expression, and then equal to 9AB, which is the GCF, times the leftovers. Now let's look at what was left over in our lists from every term. The first term, we had a 2 left over, 2 A's, and a B. So that means it's 2A squared B. Here's a plus, so we put plus. The leftovers from 9AB to the 4th, it's just 3 B's. So that second term in the parentheses is going to be B to the 3rd. Next symbol, next operator is minus, so we're going to put a minus. And then the leftovers here are 2 2's and 3 A's, so 2 times 2 is 4, A to the 3rd, 4A to the power of 3. Amazing. All right, so this form that we just wrote it out in is called factored form. We took the original expression and factored it into the GCF and what we have called the leftovers. To do this process a few times, you start seeing the shortcuts therein. One shortcut that you could do instead of doing the entire factorization like this is to find the number that goes into 9, 18, and 36 evenly, the highest number that does so. For example, the smallest number here is 9. I know 9 goes into 9, 9 goes into 18, goes in twice, and 9 also goes into 36, it goes in 4 times. So 9 is going to be my GCF with the numbers. Now, as far as the letters or the variables are concerned, the trick is to look at all of the same variables and find the smallest exponent. A to the 3rd, A to the 1st, there's no exponent, so we call it to the 1st, and then A to the 4th. The smallest exponent is A to the 1st, so A to the 1st is going to be in our GCF. Similarly, here's B squared, here's B to the 4th, and here's B. B to the 1st, right? B to the 1st is that smallest exponent, so B to the 1st is going to be in our GCF. All right. One last thing to figure out the leftovers, one last trick to figure out the leftovers. I took out 9AB from every term. 9 times 2 is 18. That's a quick way to figure out what the leftover is for the numbers. And then for the variables and exponents, the same variable is going to appear. The A is there. I'm just going to do A to the 3rd minus A to the 1st, or in other words, the exponent of 3 minus the exponent of 1 in the GCF. Exponent of 2 minus the exponent of 1 in the GCF. I'm going to subtract the exponents. I'll show you an example of that next. Let's try to use our skills to figure out the greatest common factor between these 3 terms, and then we're going to factor it using that greatest common factor. So 24x to the 2nd power, y to the 4th power, z to the 3rd power, etc., etc., etc. Let's look at the numbers first. 24, 16, and 12. Think of the number that goes into 24, 16, and 12 evenly, the largest number that does so. Can you figure it out? It should be 4. Okay, so I know that my GCF, my greatest common factor of the numbers, is 4. Now let's take a look at the x's. For the x's, this is x to the second power, this is x to the first power, and this is x to the third power. What's the lowest power that's there? Okay, it should be x to the first power. So that's the next thing that goes into our GCF. Now we're looking at the y variables, y to the fourth, y squared, and y to the sixth. Which one is the smallest variable there? I'm sorry, the smallest exponent there? Okay, it should be y squared, right? That's smaller than y to the fourth, it's smaller than y to the sixth. So I'm going to put that there. Let's finish it off here. Z to the third, z to the third, and z squared. Well, there's two z to the thirds. However, z to the second power is represents the smallest exponent. So I'm going to write z squared in my GCF. Okay, there's my GCF all done. Now what I'm going to do is figure out my leftovers. In order to figure out the leftovers, I'm just going to try to divide the numbers by each other and then each of the variables by each other by subtracting the exponents. Okay, first leftover. I know that 4 goes into 24 6 times. So my number for this term is going to be 6. And then x to the second power and x to the first power, 2 minus 1 is 1. So it's going to be x to the first power, just x. Now y to the fourth power, y to the second power, 4 minus 2 is 2. So this should be y to the second power, y squared. Whoa, not to the w cubed power. That would be ridiculous. And then last but not least, my z to the third minus z to the second, or z to the third divided by z to the second. 3 minus 2 is 1. So the leftover for z's is just z to the first. Yes. 16 divided by 4, that's just 4. X divided by x, that actually eliminates x to the first and x to the first. So there is no x term here. I don't have to write x. Same thing here, y to the second and y to the second. 2 minus 2 is 0. If you get a 0, you don't have to write that term. However, z to the third and z squared, 3 minus 2 is 1. So I do have to write a z here. The operator is plus, so I write a plus. And then 12 divided by 4 is 3. X to the third and x to the first, 3 minus 1 is 2. So this should be x to the second power. Y to the sixth divided by y squared. 6 minus 2 is 4. So that should be y to the fourth power. Almost done here. And then last but not least, z squared divided by z squared. 2 minus 2 is 0. So I don't need a z there. All I need is to close off my parentheses and I'm done. That was a procedure of factoring out the greatest common factor and writing out the leftovers. What we've just done is factoring by the greatest common factor for polynomials. That brings us full circle. Remember, folks, this was the video on factoring GCF with polynomials, identifying the greatest common factor from a list of terms, taking it out, and then writing out the leftovers. All right, folks, good luck studying.